Hello, this is Mr. Wyrick. I'm here to talk to you about 6-1, brand new chapter today, brand new lesson in the new chapter. And our new lesson in the new chapter is going to be the angles of polygons. So we're talking about what angles are formed by different polygons. Now, poly, if you remember your roots, poly means multiple, and the gon represents a shape. So we're talking about a shape with multiple sides. Typically, we start with a triangle and just move up from there, because if you only have two lines, you can't close anything in. You can't make a two-dimensional shape here. So the first thing you need to make sure you have in your notes is the diagonal. And the diagonal is connecting non-consecutive vertices on one of these polygons. So every time you have a diagonal, and I didn't draw in all of the possible diagonals on these because this is the way that they're going to explain the interior set of degrees here, all these interior angles. So what we do is we cut our shape up into triangles using diagonals, and we see how many triangles we have. So for a quadrilateral, we have two different triangles. I have just a square up here. We got a couple of different triangles from that. A pentagon up here, this little home plate shape kind of moves into three different triangles there. So the way that they come up with this formula is we take our number of sides, we subtract 2 because we can't make diagonals the other directions, and then we multiply that by 180. That'll be the sum of all the interior measures. So when we have a triangle, we have those three sides, it's 180. For the quadrilaterals, the squares, the parallelograms, the rhombuses or rhombi, you would add another 180 to make it 360. For all of the pentagons, you would add another 180 and make that into 540. So the whole way through, that's what we're doing, is we're adding up all of those measures, and it comes together to go to the next one. But this is on, let's see the page, 395, I believe, in the book. So you can look at this formula, you can see what it does, but just remember it's number of sides minus 2 times 180. The exterior angles then, which is the other set of angles that we're going to be working with for this lesson, the exterior angles have to add up to 360, and it really doesn't seem likely in this case that that's what's going to happen. But if you look at this, what I've done here is I just drew an equilateral triangle. It's equiangular, so all of these are 60. If we have this extended from every 60 is going to be 120, and 320s is 360. So we're always going to have 180 on the inside here, so the rest of the angle going in any one of those places, those are always going to add up to 360. I drew a rectangle real quick just because it's easy to look at. You can say, okay, here's a 90-degree angle, 90-degree angle, 90-degree angle, 90-degree angle. 90 times 4 is 360. From our pentagon, same kind of thing. You have to remember, though, you always extend the lines going around the shape in the same direction. So if I were to draw a pentagon here like this, I wouldn't want to extend this angle this way and extend this angle this way. That would make it to where it doesn't add up to 360. I can tell I'm doing it wrong. I just follow around the outside. So I extend this one, I extend this one, I extend this one, I extend this one, and then I extend this one. And all of these exterior angles here are going to add together to make 360. Okay, so the two major things from this lesson: the interior angles, we subtract 2 from the number of sides, multiply it by 180. That's our sum of the interior angles. Our exterior angles, the sum, when we add them all up, is going to be 360. If you have any questions, make sure to ask them in class. If I'm gone, save them until I come back, and we'll see you then.